The use of band method could apply when re-engineering is being considered as discussed in maintenance of operational systems. And overview about function points. It adds changes to improve the applicability of the system to the significant internal processing. Okay, this allows the accounting functionality not readily perceivable by the user but essential for proper operations. And next one is latent micro function points. One of the new model that is developed in 2009, which adjusts the function points using weights derived from program flow, complexity, operand and operator vocabulary, object usage, and algorithms. Okay, so the benefits are the risk is inflation. Lines of code measures reward low-level language because more line of codes are needed to deliver the similar amount of functionality. Okay, LOC measures are not useful during early project phases where estimating the number of lines of code that will be deliverable is challenging. And the next topic we are going to see is about COCOMO 2, a parametric productivity model. COCOMO means the abbreviation is constructive cost model 2. Okay, it is a model that allows one to estimate the cost, effort, and schedule when planning a new software development activity. So whenever we are planning to develop a software, the first main thing we need to keep in mind is COCOMO model. Okay, so COCOMO 2 is the latest major extension to the original COCOMO 81 published in 1981. It consists of three submodels, each one offering increased fidelity. The further along one is the project planning and design process. Listed in increasing fidelity, the three submodels are called as, there are three submodels in COCOMO 2. One is the first one is application composition, second one is early design, and third one is post architecture models. Okay, COCOMO 2 can be used for the following major decision situations. So it is used in many decision situations. Some of the important decisions are, first one is making investment or other financial decisions involving a software development effort, setting project budgets and schedules as a basis for planning and control, deciding on or negotiating trade-off among software cost, schedule, functionality, performance, or quality factors, making software cost and schedule risk management decisions, deciding which part of a software system to develop, reuse, lease, or purchase, making legacy software inventory decision, what to modify, phase out or outsource, etc. Setting next investment strategies to improve organization software capability, deciding how to implement process improvement strategy such as the provided in the SEI CMM. So these were the some of the criteria for which we are using COCOMO 2. So for taking major decisions, we need to incorporate COCOMO 2 model in that. Okay. The original COCOMO model was first published in the year 1981 and reflected the software development practices of the day. In the ensuing decade and of software development techniques changed dramatically. These changes include a move away from mainframe overnight, batch processing to desktop-based real-time turnaround. These changes and others became to make applying the original COCOMO model problematic. The solution of the problem is to relearn the model of that is developed in the year 1990s. After several years, the combined effort of USC CSSE at UC Irvine and the COCOMO 2 project appreciation organizations, the result is COCOMO 2. Okay, this is about COCOMO 2 model. The new improved COCOMO is now ready to assist professional software cost estimators for many years to come. Next topic we are going to see is about the staffing pattern. Putnam was the first to study the problems of what should be a proper staffing pattern for software project. He extended the classical work of Nodon, who had earlier investigated the staffing pattern of general research and development type of projects. In order to appreciate the staffing pattern desirable for software project, we must understand both Nodon's and Putnam's research. So first one is Nodon's work. Nodans studied the staffing pattern of several R&D projects. So R&D is nothing but the research and development projects. He found the staffing pattern of R&D projects to be very different from the manufacturing or sales type of work. So he found that first the categories of different team working under the development process. Okay, staffing pattern of R&D types of projects change dynamically over time for efficient manpower utilization. He concluded the staffing pattern for any R&D projects can be approximated by the Rayleigh's distribution curve. So this is about Norton's work, and next one is Putnam's work. Putnam studied the problem of staffing of software projects. He found that staffing pattern for software development projects has characteristics very similar to R&D projects. Okay, he adopted the Rayleigh's Norton curve to relate the number of delivered lines of code to effort and time required to develop the project. Initially, less number of developers are needed. As the project progresses and more detailed work is performed, the number of developers increases and reaches a peak during productivity delivery. After delivery, the number of project staff falls consistently during the product maintenance. So this is about Putnam's work. Thank you. This is about second unit in software project management.